All right, everyone, happy Monday. We are going to continue working on solving systems of equations. Like I said last week, I know this is new and I'll still be available on Zoom. I'm going to be on every day at 10:30, so if you need help, feel free to pop on at that time. So hopefully I can answer your questions for you if you're stuck. Last week we actually looked at if an ordered pair works in a system of equations. Today you're actually going to solve the system of equations. So being able to tell what x and y are and being able to figure out the values for those. So kind of day two of all of this. Okay, we're going to look at two scenarios today. And the first scenario is solving the system of equations when both equations are already solved for y. And that really makes it kind of nice and hopefully pretty simple. Okay, so looking at this system of equations, we have two equations, we have two variables, x and y. We're going to solve the system of equations when the equations are solved for y. Okay, so in order to do that, okay, we are solving by substitution, and that's exactly what it means. You're substituting a value in. So this first equation says y equals x plus 3. Well, the second equation says y equals 2x plus 5. Well, let's take the first equation. If this is what y equals, let's substitute that into the second equation for y. Okay, so I'm going to rewrite this, and it's going to say x plus 3 equals 2x plus 5. Now we have an equation that just has one variable. Yes, the variables are on both sides, so we have to be able to solve that equation. Okay, so we have to take the variables on one side and the constants on the other. So I'm going to do this. Variables and constants, just like we did in the equations unit. I'm going to subtract 2x from both sides. Be really careful with positives and negatives. So we have negative 1x plus 3 equals 5. And then subtract 3. And you have negative 1x equals 2. And then we have to divide by negative 1. So x equals negative 2. Well, that's really nice. Once we know x, we can figure out y. So I'm going to go back to this equation. Give me a second to erase this. Okay, I'm going to go back to this first equation, and it really wouldn't matter which equation we use. I'm going to use the first one. And if y equals x plus 3, and we already said x equals negative 2, okay, I'm going to substitute that in for x. So y equals negative 2 plus 3. And so that means y equals 1. So my answer, okay, we write our answer as an ordered pair. My answer is negative 2 because x has to come first, and then 1. Okay, so that is our answer for this problem. Now we can check that. If y is 1, x is negative 2. Negative 2 plus 3 is 1. That works. If y is 1 and x is negative 2, you have 2 times negative 2 is negative 4 plus 5, which is 1. So we know that this ordered pair works in that system of equations. Okay, let's try another one. Okay, this time we have y equals 4x minus 6 and y equals x plus 3. We're going to take this and substitute it in for y. So we have 4x minus 6 equals x plus 3. And then we're going to solve that. I'm going to put the variables on one side and the constants on the other. So I'm going to subtract an x from both sides. So we have 3x minus 6 equals 3. And then add 6 to both sides. So we have 3x equals 9. And finally divide by 3. So x equals 3. Okay, then now that we have x equals 3, again, you can pick either equation. This time I'm going to pick the bottom one. Y equals x plus 3, but I'm going to replace the x with 3. So y equals 3 plus 3, which is 6. Okay? So there's your x and y. So we put them into an ordered pair. So we have the ordered pair 3, 6. And we can make sure that works. If y is 6 and x is 3, 4 times 3 is 12. 12 minus 6 is 6. And this is 6 and 3. 3 plus 3 is 6. So our ordered pair for this equation, this system of equations works. Okay. I am not going to do this third one. I think hopefully with the 2 examples you see what's going on there, and that seems to work okay. Now we're going to look at another scenario, and this one says you're going to solve the system of equations when only one of the equations is solved for y. So again, that's not really that hard. If you look at this system of equations, we don't have both of them solved for y, but just one. So I'm going to take this second equation because it is solved for y, and we're going to substitute that in for y. Okay, now here's where we have to be really careful. When I substitute that in, it's negative 5x plus 3, and then we have to put it in parentheses. Negative 5x plus 18 equals 14. Okay, now we have to use the distributive property first. Do not try to add first. We need to distribute. So I distribute and I have negative 5x plus negative 15x plus 18 times 3 is 54, I believe, but I just want to make sure. Yep. So that would be 54 equals 14. And now we're going to combine like terms. So we have negative 20x plus 54 equals 14. And then we're going to finish solving this. So we're going to subtract 54 from both sides. Negative 20x equals negative 40, and divide by negative 20. So x equals 2. Well, that's a pretty nice number. Now, I am for sure going to take that x and substitute it into the equation that's already solved for y. So we have y equals negative 5 times 2 plus 18. That's negative 10 plus 18. So y equals 8. So our ordered pair is 2, 8. Now we can check just to make sure that that also works in the first equation. If x is 2 and y is 8, this is going to be negative 10 plus 24, and negative 10 plus 24 is 14. So it does work. So my answer is 2, 8. Okay, let me just go through one more just to make sure we've got it. Okay, the second equation is again solved for y. So we're going to take that and we're going to substitute it in for y. So I rewrite everything. You guys, it's super important that you're rewriting this. 3x minus 4, and then in parentheses, the whole part of the equation there, 7x plus 13 equals 23. Okay, now here's where we have to be really careful distributing. In this particular problem, that 4 is negative. So when I distribute, okay, we have the 3x, we're going to distribute negative 4 to 7x, which is negative 28x, and then negative 4 to a positive 13, and you get negative 52, or minus 52 equals 23. We combine like terms, so this is going to be negative 25x minus 52 equals 23. Okay, we keep solving. We have to add 52 to both sides. So you have negative 25x equals 75, and then divide by negative 25. So you have x equals negative 3. Okay, now is our chance to go back and solve for y. So x equals negative 3. I'm going to put that into this equation. Y equals 7 times negative 3 plus 13. That's negative 21 plus 13. Remember, one of these is negative, so 21 minus 13 is 8. And so y equals negative 8. And so I have the ordered pair negative 3, negative 8. Now, we do want to go back and double check that that works in the first equation. So if I put negative 3 and negative 8 in here, negative 3 times negative 3 is negative 9, minus 4 times negative 8 is negative 32. Keep, change, change. So negative 9 plus 32 is 23. So it works. So my ordered pair is correct. Okay. Now your homework is going to be a few problems on Cami. Because I need to see your work. You guys, I hope that you understand that if you actually work out the problem using that process, it goes a little easier. So I'm going to put it on Cami, but then I'm also going to post an answer check for you so that you can plug in those answers to each problem as an ordered pair and see that it works. Okay, so you have some immediate feedback, and I will still respond to your homework and tell you your score and how you did on it, but that way you know if you have them right or wrong. Okay, so that's what you have to get done tonight. Good luck. Have a good day.